All right, we have here the solution to quiz 1. It's helpful to always make sure we know what we're solving for. We're asked to find R3. So R3 is the resistance of this third resistor. If we're looking at nodes, all of this and all of this are two different nodes, A and B. So everything is in parallel. Over here we have our V total is E 240 volts. Our I total is 40 amps. Use our favorite law, V equals IR, Ohm's law. Rearrange and solve for our total. V over I, 240 volts over 40 amps. And our total is 6 ohms. So one way to solve this is that we could put our total, see that they're all in parallel, R1, parallel with R2, parallel with R3. Plug all that in. 6 ohms is equal to 1 over 10 plus 1 over 20 plus 1 over R3 to the negative 1. You can do a solver. You can do the algebra. Either way, R3 will come out to 60 ohms here. Another way to do it is to see that they're all in parallel and do KCL and say that 40 amps is going in and what's coming out is I1 plus I2 plus I3. Well, if they're all in parallel, they all have the same voltage across them. I1 is 240 over 10. I2, same voltage, 240 over 20. And we have 240 over R3. Can also do the math there, subtract the 24 from each of those, rearrange, and you get to, you can subtract the 24 from the 40 and the 12 from the 40 and rearrange the equation and you get R3. Next one is the current divider rule. Always helpful to label nodes. There's a node. Everything here is a node. There's one node in between there. And then all of this is the bottom. And what we see here, based off what's already labeled B and C, so I'll go A, D, and E. B and C were already labeled up here for me. And we can combine them. 100 is in series with the 50. Those are in parallel with the other 50. All of those together are in series with the 40. All of that is in parallel with the 160. And everything together is in series with the 20. Simplify out, 150 paralleled with 50 plus 40 paralleled with 160 plus 120. 37.5 plus 40 paralleled with 160 plus 20. 77.5 parallel with 160 plus 20. 52.12 plus 20. And our R total comes out to 72.12 ohms. I wanted to redraw these circuits along the way. So I'll do it black. So here's that first combination. And here's the 37.5. There's the 40. Oops, there's the 50. Here's the 40. Oop. There we go. 150. Added the 100 and the 50 makes 150. Put those together and I redraw again. 37.5, 40, 160, 20. Go this way. There's the 52.12. And here's the 20. And I can see there's my total for everything. But now when I'm doing the current divider rule, so we found the R total. Now we're going to solve for IX using the current divider rule. So current divider rule is IX. And we're dividing up some current. IEQ is being divided up. REQ is the parallel. CDR is for parallel. right? That's a key thing because what is in parallel here? Well, look at it's after the 20 ohm resistor. Node A, up top here, node A, that is where it divides. The current divides there into the parallel resistors and it rejoins down here in node C. So between A and C is where the dividing happens. So whenever I'm looking at my REQ, I'm only going to take the 52.2 from right here. That right there, because that is where between A and C, that is the R equivalent between the node of dividing and the node of rejoining. So if I put all those back in together, IEQ 15 amps, 52.12, the RX, the branch that I'm looking at is 160, or the path, everything in that path, I'll highlight in yellow here, everything in that path is IX, and it just happens to just be the 160 in this case. So now IX, plug that in, comes out to 4.88-ish. My rounding may be off there, you can check it, but it's right around there. All right, next problem number 3. What is the value of I? Well, this is a series circuit, right? So what comes out of this voltage source goes through every single resistor in this entire circuit. So if I can find the value of I in one resistor, I can find that I total, which I have V equals IR, the voltage across R1, the current through R1 times R1. Rearrange for IR1, V across R1 divided by R1, 12 volts, 8 ohms, 1.5 amps. Because it's in series, therefore I total equals IR1. What is the equivalent of all three? Now I can use our favorite law again, V equals IR, and rearrange for R total equals V total over I total. V total 24 divided by 1.5 gives me 16 ohms. Another way to look at this is to say, if we know that 12 volts took, or rather R1 took half the voltage of 12 volts, right? R1 took 12 volts, half the voltage. Then the remaining 12 volts is divided between R2 and R3. Since we know that R2 is half of 8, we can see that the voltage across here should have been 6 volts, which means this is 6 volts, which means this is 4 ohms as well. You could do a KVL, you could do your circuit analysis, but 8 plus 4 plus 4 also comes out to 16. Last problem here, we don't know any of the R's, but we do have some currents here. And so here's a node and here's a node right there. Using KCL, what goes in must come out. And so for the first one, 120. 120 equals 85 plus IX. IX comes out to 35 milliamps. It divided in the node A, the 85 continued on, and it divided again. Note that that's 0.02 amps, which is 20 milliamps. Right here is 20 milliamps. But I can do KCL again, do it down here. KCL. And now 85 is what's going in, and coming out is 20 plus IY. Pretty simple math. IY comes out to 65 milliamps. And there is quiz number 1.